Lesson 3 or 4, using Z-score tables. For this lesson, you will need to have the Z-score tables handy. The Z-score tables look like this. They are in your workbook. I believe they are at the very end of your workbook, but you should also get a handout in class. I'll also put one on the website, so you could just download it from the website if you need to print one off at home. So recall that the standard normal distribution curve looks like on the left or right. So this is a good thing to put on your study sheet. The numbers on the horizontal axis represent Z-scores. So these are our Z-scores. Remember that the middle is our mean, which is 0, and our standard deviation, so mean is always 0 on a Z-score normal distribution graph, and your standard deviation is 1. The Z-score table is located on the last 2 pages of the workbook, given the area to the left of a particular Z-score value is shown. So on that will give you the area to the left of a particular Z-score. So on our table, if I looked at, for example, a Z-score of 2.51, the tenths value is on the vertical axis, and the hundredths is on the horizontal axis. So I'd first look at 2.5. 2.5 is here, and then we want 2.51. So 2.51 would be 99.38% of the data is left of that, or 0.9938 of the area under the curve is to the left of 2.5. So because it's always from the left all the way to the negative infinity, that would be the area under there. Okay, so back to your workbook. Properties of Z-score. So again, we've talked about these the other day. They are very important. So your Z-score, I'm just going to grab a highlighter. Remember that the data value describes the number of standard deviations above or below the mean. That's what your Z-score does. How much above or below the mean it is. A negative Z-score indicates that the data value is below the mean, and a positive would be to the right of the mean or above the mean. The Z-score table gives the area under the curve to the left of the Z-score. It also could be a percentage to the left of the Z-score. So we just multiply our area times 100. Area multiplied by 100 is going to give you your percent. And probability that random chosen value is to the left of the Z. So it also gives us probability. Probability. So it can give us area, percentage, or probability. They all represent the same. And last, the mean, median, mode is a Z-score of 0 in a normal distribution. Using the Z-score tables to calculate areas under the normal curve. On the normal curve, shade the region where Z is less than -3. So it helps if we draw in our Z. Here's my Z-score 0. So we want to always draw 3 lines, 1, 2, 3, and then again 1, 2, 3 to the left, -1, -2, -3. It asks us to shade when Z is less than -3. So when Z is less than -3, that's our shading. A highlighter will be very helpful for the shading in this unit. Or you can just use your pencil to shade. Now, these two things are the same. When I say area -3, the area under -3. So it says determine the area under the curve for Z less than -3 using our tables. So it's -3.00. So we always need 2 decimal places. So we grab our Z-score table. I'm on the negative side. So tenths, -3.0 is right here. And we want 3.00 for -3. And here we can find 0.013. 0.013. So the probability, determine the area. The area is 0.0013. Verify your answer using the standard normal curve above. So notice how on our curve above, less than -3 was 0.0013 or 0.13%. Okay, let's look at another problem. Use the z-score table to calculate area under -2. So that's the same thing as z less than -2. So let's draw in 1, 2, 3 on each side, bars, 1, 2, 3, 1, 2, 3. And so we'll put in -2, and we want to shade to the left of -2. It's always to the left. So what's the area or the probability under -2? So we grab our z-score table. Now again, two decimal places would be -2.00. So I look up for -2.0 first, the tens value, and then 0, 0. So -2.00 is 0.0228. 0.0228. Now area under the curve for 1. So add in our 3 bars to the right, 3 to the left. So 1 would be here. Now we want always to the left. So the area under 1, I'm going to shade all this. There's our z-score of 1. And you might even want to draw in 0, 1, 2, 3. You don't have to though. And so the area less than 1, we grab our z-score table. Now it's a positive, so I want the other side. And we 1.00, tenths, hundredths are here. So look for 1.0, which is right here. And then we want 0, 0. Backwards on this side. So 0.8413. 0.8413. Or you could say 84.13% if it wanted a decimal. And area under 2. So again, let's draw in 1, 2, 3. So 2's here, and we want the area under 2. So if you had a highlighter, it's actually a little bit easier. We want the area under 2. So shade that in. Okay. So two decimal places, that'd be 2.00. 2.00. Keep grabbing the wrong one. There it is. So 2.00. Let's erase these ones. 2.00 is 9772. 9772. 0.9772. So it says verify the answers using the standard normal curve on the previous page. So really quickly, if I wanted less than 2, I would have had to add these two values together. 0.0. Grab my calculator. So the first probability was 0.0013 plus 0.0215. And that gives us that 0.0228 that we had first. Okay, the same idea for the other ones. We'd have to add in all those areas. So let's move on to the next question. So determine the z-score table. Determine the area under the curve for a standard normal distribution for each of the following z-score intervals. Then convert each of the areas to a percent to the nearest hundredth. So let's draw in again our 3 bars left and right. And then we'll put in our z-score. So our z-score we want is -2.15. So if this is -1 here, -2, -2.15 would be to the left of -2. So that's our z-score of -2.15. We want to shade to the left, always to the left. So notice Z is, this symbol means less than. Less than. Okay, so looking with our z-score sheet, so Z is, we want the negative, -2.15. So tenths place is on the left, 2.1, -2.1, and 5 is here. So we match them up. That's 0.0158. 0.0158 is the probability. And you could also write that as area under -2.15. Okay, so what if we want greater than negative 2.15. So if we draw in our bars, 1, 2, 3, 1, 2, 3, and negative 2.15 was here, and we want to shade to the right because we have greater, z is greater than. Now our graph is only for less than, right? Always to the left, not to the right. But we know that the total area under the curve is equal to 1. And if we know the area to the left, then you could figure out the area to the right. How do we do that? Well, the total area under the curve is equal to 1. So if we do 1 minus the area to the left of negative 2.15, we'll get the area to the right. So we already did this previous question, and we got our area to be 0.0158 to the left. This area here was 0.0158. And so since it always adds to 1, everything, we have 1 minus that area. So 1 minus that, 1 minus the 0.0158 is going to give us 0.9842. 0.9842. And so that would be the area to the left. How about between two values? So between negative 2.15, so let's do a quick rough sketch, negative 2.15 and 2.15. And we want the area in between. And remember, those areas on our sheet only give us the area to the left. So how could we get the area between two values? Well, we'd have to find the area under the larger, so all the way to the left, all of this, right? And take away this small area to the left of the smaller. So the larger minus the smaller. So area of under 2.15 minus the area under negative 2.15. So let's look up 2.15. So grabbing our sheets. Where are you? Grabbing our sheets. Here they are. So 2.15, positive 2.15. So 2.1 is right here. And 5.05, so 2.15 would be 0.9842. 0.9842 be the area under 2.15. And area under negative 2.15, we already found that in the first part, 0.0158. So we're going to subtract those two. 0.9842 minus decimal 0.158, and that gives us 96.84%. 0.9684 would be the area under between negative 2.15 and 2.15. So let's try another one. Determine to 4 decimal places the area under the curve for a standard normal distribution for each of the following z-score intervals. So z is less than 2.08. So approximately 2.08 is approximately over here. We want less than. Less than. So everything to the left, which is nice because that's what our chart is set up for. We want the area, so the area below 2.08 is equal to, so grabbing your table, we're at positive 2.0 and 8 is here. So we want 0.98, 0.9812. 0.9812. Okay, let's try another one. When z is greater than 0.92, so if we roughly sketch, just use gray. So here's our 1, 2, 3. It's very faint. So 0.92 would just be below 1, a z-score of 1. And we want greater than, z-score greater than. So we're looking for all this area. So whenever it's to the right, we always have to go 1 minus. Whenever it's to the right. So 1 minus the area under 0.92. So if we get the area to the left, subtract it from 1, that will be our answer. So 0.92, 0.92 gives us an area of 0.8212. 0.8212, and if I subtract that from 1, we get 0.1788 is our answer. 0.1788. All right, next question. Area between negative 1.75, so I'm just going to grab, if you have a pencil, you can just do this lightly. So here's our 3 bars, 1, 2, 3, 1, 2, 3. This will help me sketch. Okay, negative 1.75 will be just above 2, a little bit above 2, negative 2, sorry, and negative 1.2. So it's a small little area because there's negative 1. Move this guy over. Oops. Nope, don't want to do that. So negative 1.75 and negative 1.02. And we want the area in between there. So whenever we want the area in between two values, we're going to go big minus small. So the area left, the big one, is negative 1.02, the one on the right, minus the area under negative 1.75. Because if I get this whole area for under negative 1.02 and then the area under 1.75, we subtract that, take that away, what we're left with, see these two parts, what we're left with is the part we're looking for. Okay, so let's look up those values. Negative 1.02, negative 1, so we're a negative chart, negative 1.0 and 2, so over here, erase these other things. Negative 1.02 is right here, so 0.1539. 1539. It should always be positive. So if you get a negative answer, you know you mixed up the order of your subtraction. Area is going to be always positive. So now for negative 1.75, negative 1.75, so negative 1.7 and then 5. It's right here, 0.0401. 0.0401, and now we're going to subtract the 2. So the area to the left of negative 1.02 was 1.1539 minus 0.401. And what does that give us? That area in between is 0.1138. If we ever wanted a percent, we just times it by 100. Okay, 2 more questions for this first half of this lesson. How do we get the area between these z-scores? Well, let's do a rough drawing so we know where our z-scores are. So I'll make this gray. 1, 2, 3, 1, 2, 3. So we want it between negative 1.3 and 2.65. We're looking for the area in between. Now for today's lesson, we're learning how to use these charts. In the future, I'm going to teach you how to do this on their calculator. But it's really important that you understand how to use the charts before you learn how to use the calculator. Okay, so whenever we're doing area in between 2 points, we want to find the area under the large minus the area under the small z-score. So looking up our areas again, 2.65 really helps having your thing right in front of you. So 2.65, we want the positive side. 2.6, and then I find the 5. So 2.65 right here. 0.9960 minus negative 1.3. So grab my table, now the negative. Yeah, here we go, negative 1 point, what was that? 1.3, negative 8.3, negative 1.183, negative 1.8, it's right there, and 3 is over here. So we line up, they meet at 0.0336. 0.0336. So subtracting these two values, 0.9960 minus 0.0336 gives us the area to be 0.9624. And that's the probability. If I wanted an area, I would just times it by 100. Okay, last question. Between 1.83 and 2.65. So this time it's a positive. So on this side, 1, 2, 3, we're looking at between 1.83 over here and 2.65. So we can't use the values we had before. So how do we find this out? Well, the area under 2.65 minus the area under 1.83. So to the left of 2.65, we look it up on our sheet. 2.65, we need the positive side. 2.65, we had that from before, 9960. So that one stayed the same, but the 1.83, we want the positive. 1.83, so 1.8 and 3 meets at 0.9664. 0.9664. And now we subtract. 0.9960 minus decimal 9664 gives us an area of 0.0296. Okay, so that's the lesson for the first part of this lesson, and then the next day I would cover the next lesson. So I'm going to continue on here. So how do we go backwards then? What if we know our area and we're trying to figure out our z-score? Now, one thing you need to know about our table is that it's never a percent, it's always a decimal. And so if they give us a percent, the first thing we want to do is change that to a decimal. So for example, the area they say underneath Z1 is 17.62%. So we want to change that to a decimal. So basically our situation is we want to find the area under Z1 is equal to 0.1762. So we're just working backwards on our table. What we want to do is look up on our table who has an area, what z-score has an area of 0.1762. So on my z-score tables, I'm just going to clear all this, make it nice and clean. You can see on this negative side, looking at the numbers inside, I want 0.1762. And so I find that area inside, and I found it, right? And we look at the z-score, that's negative 0.9 and 3. So the z-score would have to have been negative 0.93. So the z-score, negative 0.93. That would give you that area. So we're just working backwards in this case. Now about the next problem. Now remember, when we look up the z-scores, it's always to the left. So they tell us that the area on the right is 0.1492. So what would have been the area to the left? Because on our table, the area is always the areas to the left. So we want to get this area here, which is 1 minus 0.1492. A little trick is all your numbers need to add to 9 and the last adds to 10. So it'd be 8 plus 1 is 9. So it'd be 8. What plus 4 equals 9? Well, 5. And then 0, already 9, and the last one we want to add to 10. So it's a little trick for subtracting from 1, or you could just use your calculator. So we know that the area under Z1 should actually be 0.8508. That's this area to to the left of our z-score because our chart is always to the left. And so what would our z-score have to be to give that area? We look up on our table, so 85. So we know it's going to be on the positive just by looking at it. So we can grab our chart here, and we want to go to the positive. 0.85, I think it was 8507. 8508. 8508. So we look for 0.8508. So until you find it, there's some 80s over here. 8508. Now, if it's somewhere in between two values, you're going to find the closest z-score. In this case, it's right on 1.04. 1.04. So our z-score would have been 1.04. Okay, how do we approach this guy? We know this part is 0.258. Now on our chart, it's everything to the left. Do we know what this area is all to the left of 0? And the answer is yes, we should know, right? Everything to the left is 50% or 0.500. So the area to the left of Z1 is actually the sum of those two added together, 0.7580. So now we can look up the area of 0.7580 on our table. 7580, 76, until we find it. 7549.80. So that would have been 0.70, a z-score of 0.70. 0.70. Okay. All right, so in order to find Z1, we need the area to the left, this guy right here. And then Z2, we need the sum of the area here plus the shaded part already given. So let's start with finding the area left to Z1. We know everything under 0 adds to 50%. So we can find this area over here by taking our 0.5 and subtracting 0.2145 and 0.1292. Subtracting those other two scores, what's left over is our area to the left of Z1. So with my calculator, I'm going to have 50% under the curve there, minus 0.2145 and take away another 0.1292. And so 0.1563 is the area to the left. 0.563. So now I can look for, if I know the area under Z1 is equal to 0.1563, then we can figure out what Z1 is. So with my tables, 1563, we're going to look on the negative side. So 1563, looking up on our chart, C17, go to 1562 is close enough. 1562. So that would be a z-score. That's the closest one. Negative 1.01. Negative 1.01. Negative 1.01. So that was the z-score 1. We need to find z-score 2 now. So in order to figure out area under z-score 2, I'd have to add together the 0.1563, 1563, and the 0.2145, because we want the whole area to the left of Z2. So adding those together, we have 0.1563 plus 0.2145 gives us an area of 0.3708. So now that we know the area left of Z2, we can use our chart and look it up, 3708. So 3708, 3707, that's the closest to 3708, would be negative 0.33. So writing that in, Z2 then had to be negative 0.33. And there's Z1. Okay, so that's the end of this lesson. The homework for here is 4 to 7.